All right, let's do it. So we're going to be talking about solving equations that have rational expressions in them. You don't need to write this page, but I just want you to just know what kind of math skills we'll be using to do that. So first of all, if you multiply a fraction by its denominator, it cancels the denominator out, right? You learned that? So if you multiply this by 4, those go away, and you're just left with 3. Right? So we're going to be using that little skill today. Another math fact we're going to be using is this little math fact here. If you multiply one side of an equation, it's okay, so long as you multiply the other side. So I'm allowed to multiply by 2 over here, so long as I also multiply by 2 over here. And so I can create a new looking equation like that. Okay, we're going to be using those two skills to solve the equations today. So let's go ahead and take a look at some of those. We'll start off with our first one there. Go ahead and write down example 1, please. Okay. So let's go ahead and do what we've been doing. And let's start by rewriting the problem here so we can see the original before we start messing with it. Okay, so what I'm going to do here is I want to get rid of the denominators, and we just talked about how you do that. You get rid of your denominators by multiplying by those denominators, okay? Now, if I multiply by this side by a denominator, I'm going to do it to this side, so you have to do it to all 3 of them, okay? Now, we have 3 different denominators here. I've got x to the power of 2, I've got 2x, and I've got 4x to the power of 2. Technically, it doesn't matter which one you start with, but if you want to maybe save yourself a little bit of work, you want to pick the one that's the biggest. So, but what do I mean by the biggest? Well, maybe it has the biggest coefficient, like 4 is the biggest coefficient. Or the one that has the biggest power, like a power of 2. Now, this one here has both of those, so that's what I'm going to multiply by. But sometimes you can't really tell necessarily which one's technically the biggest one, so it doesn't matter. But if you can tell, I'd recommend multiplying by the biggest one. So we're going to multiply everything by the biggest denominator, which is 4x to the power of 2. So I'm going to put times 4x squared here, times 4x squared here, and times 4x squared here. So step 1 is to multiply. Okay. Now, the one that we multiplied by, just cross it off. That was the point of it, is that it would cancel out the denominator. But for the other one, we're going to go ahead and just simplify them. So 1. So for this one, we have 1 times 4x squared. That would be 4x to the power of 2 over 2x. And then here, if we multiply these, we get 8x to the power of 2 over x squared. All right. So that's the end of our first step. Now the next step, though, is we're going to reduce. Okay? So let's take a look here. What can I reduce by? How would we simplify that? 8x to the power of 2 over x to the power of 2. We could divide out the x to the power of 2's, right? So we could just go ahead and cross those off. That's gone. That leaves me with 8 minus. And I think we could reduce this one also. It's just going to be 2x. So now if you didn't know that, let's talk about why. So this is something we did a little while ago. For the coefficients, you divide them. So 4 and 2 can both be divided by 2. So we'll divide the 2 out. You're just left with 2 there. And then the x's, right? We have 2 x's on the top and 1 x on the bottom, right? So you can think of it like this. X squared means we have 2 x's. Well, one of them goes away, so you're just left with x on the top, right? So it's 2x. And we have no more fractions. Now, sometimes you'll still have fractions after that, and we just have to repeat the process. You have to multiply by that denominator and then reduce again. Okay, but your first 2 steps are multiply and then reduce. If you have a fraction after that still, just do it again. All right? But we don't have any more fractions, so now we're good to just solve. So let's go ahead and solve one here. Next step. So what would we do to solve this? Minus the 8 on both sides. That goes away. See, that leaves me with negative 2x equals negative 7. And then what? Divide the negative 2. So these go away. And now I have negative 7 over negative 2. The negative cancel those, so we'll just put that. And that's our answer. So we solve for x. So we have an equation over here, right? And we're trying to find out what's the value of x that will make this equation true. And the answer is x is 7 over 2. Okay? So that is our first one there. Let's do another example here. We'll call this a guided practice. So Taylor, what's first, sir? You want to multiply to get rid of the denominator. I agree. You want to do us the honors. What would you pick to multiply by? Okay. So he's chosen the 2b squared. So I'm going to multiply everything by 2b squared. Keep your binomials in parentheses, guys. Okay. I mentioned there's one that we could just kind of cross off right away. So, Arsenio, which one can we just cross off right away? Yep, because that's the one that we multiplied by, right? The 2b squared. So here, these just go away. Completely done. All right. But for these other ones, we'll go ahead and multiply them together. So this one here is going to be 2b squared times 4 is 8b squared. And then over here we have 6 b cubed over b squared. All right. Jaden, do you know what is next?
What's it called? You like divide, right? Like get rid of the similar.
Kinda, yeah, kinda. So like, what we're gonna do is we're gonna reduce. So I'm gonna give you guys a second here, and it's like dividing. So both of these can be reduced. So I'm gonna ask you guys what you get afterwards. So go ahead and try that out. I'll give you a second, and we'll see what you get. All right, so what do you think, Michaela? What'd you get for this first one here? How about this one? 6b. So there's 3 b's on the top and 2 b's on the bottom, so we just take 2 away from both of those and we're good to go. All right. Someone want to volunteer for this one? 8b over 3. Basically, we have 1b on the bottom here, 2 on the top, so we just take 1b away from both of those. All right. Let's see. So, Azul, what do you think would be next? What's that? So that is the third step after you reduce is to solve. So nice observation there. However, we still have a fraction, so we need to kill that fraction. You know what we do? We multiply everything by 3 now. Yeah. So sometimes you still have a fraction. You got to do it again, right? So I'm going to multiply everything by 3 now. Right. So for our first one here, well, I guess I could ask you guys. Victoria, what do we do in this first one here? Okay. So on the first one, these just cancel out. So it's going to be 8b. Sophia, what would you say we do on this one here? Yeah. And more specifically, a special kind of multiplication called distribution, right? So you want to put it to both. Now, notice how there's a negative in the front here. When there's a negative in the front, you're multiplying by a negative. So that's going to be negative 3b minus 3. And then over here, we're also multiplying, so that would be 18b. Okay. Dianese, what would you do next? I'm sorry. Yes, now we're ready for the solving step. So good, because there's no more fractions, right? So that means solve means get the b all by itself. So Adelina, if I wanted to solve this equation, what would I do first? Reduce 8 and what? Okay, how would you do that? Kind of. We're gonna subtract it. So, what now? That would be fine. Like, here's what I was thinking. You were thinking like minus 8 here, minus 8 here. You could do that. My suggestion though would be to combine your like terms first. So, why don't we start there? 8b take away 3b is 5b. So my suggestion would be to combine like terms first. Daniel, what would you say to do next? Okay. So minus the 5b on both sides. I agree. And Arthur, last step. No. We want to get b by itself. Okay, there you guys go. Alright, so we did 2 problems, but the idea there is basically, multiply by the denominators, and then you're going to reduce, and then after that, solve, right? Sometimes you have to multiply more than once, though, to get to your final answer. Alright, so I'm going to let you guys try 2 problems here. There you go. Go ahead and try these 2 problems. So we got here 104. So I'm going to give you guys about 15 minutes. And then we'll maybe about 10 minutes, and then we'll see how you guys do with them. And then we'll go on from there. So we have number 4. Hopefully you guys checked your work with that. But let's go through the next one. Un momento, por favor. Got my technology things to be going through here. There we go. Let's get rid of the directions so we have a little space. All right. All right, well, let you guys walk me through this here. So, Jalen, what did you do first on this one? Great. I lost my pen. There it is. And what did you multiply by? Good. I agree. I think that would be a good one to pick. So let's put our binomial in parentheses, and we're going to multiply everything by 2 and 2. All right. How's about Chloe? What now? That's funny. Let me simplify, but can you be more specific? Okay, we will do that. Before I do that, though, I like to cross something off. That's what I look for, yeah. So this guy here is going to go away, right? So let's do that first. So we have a 1, and then we can go ahead and do that next step. You said multiply, right? So what will this become if I multiply them? Good. Equals. And how about this one? I'm going to stick with distributing because I think students prefer that way, but there's actually a way we could not do that. So what would that be? Mm-hmm. Mm-hmm. Great. All right. Thank you, Chloe. All right. No Khalees. Let's see. Odin. Well, what's next? We do want to reduce. So we want to reduce here, and we want to reduce here. So, Odin, if I reduced this, what would it come out to be, this first one here? Yeah. So the 2's go away, right? We have 2 n's on the top and 1 on the bottom. So if I just take an n off the top, I'm left with 1 n on the top. And if I take an n off the bottom, there is no more n on the bottom. All right. And we can do that here as well. Only difference is this time, Odin, how many n's can we take away? Yep. So long as it's all 3 of them. Now this was new. I don't think we had this in our examples where there's 3 of them, right? There's 1, 2, 3 pieces. When you have that, we just reduce like normal, but just make sure you do it to all 3. So the only thing that all 3 of them have in common is an n to the power of 2. So I can take 2 n's out of everything. So if I take 2 n's away from this, now it's just 2n. If I take 2 n's away from this, it's just 12. And if I take 2 n's away from that, it's 1, but you don't need to put a 1 on the bottom. All right? So there's that. All right, let's go ahead and take a look at our next step there. Haley, what's next? Good, we want to solve. Now there's a lot to do there, so what does that mean exactly? So we want to get the n by itself. So Marlena, what would be the first step I want to do to solve this? Okay, and how would I move it? What mathematical operation would I do to move it? Which one? Yes, subtract. Good. So this goes away. And this is a 1. 1 take away 2 is -1. Sweet. All right. Now what? Anybody can answer. I'm out of cards. So.
Combine the 12 and the win.
Negative 11. And then?
Times by 85.
Times it by 85. That's right. No. You're going to divide by negative 1. And you get, not m, you get n equals 11. All right. So, that's solving equations. Yep. So there are different ways of doing it. So, you know, maybe someone might have chosen to multiply by just 2n instead of 2n squared, or something like that. Or maybe in the solving step, they didn't, maybe they moved these over to the other side. There's a lot of different moves, but so long as they're all legal moves, it's okay. So, yeah, there are different ways of doing it. Hey.
Is that all?
That's all, folks. Name the cartoon character. Who is it? Nice, good job. That's all. A little old school for you guys, but you got
it was
it.
a pig.
Hey, what the heck?
Porky pig.
I think you're right.
It is the pig.
Do they both do it? I'm gonna have to chat GPT this now. Now my integrity as an old person is on the line. I have to look for that. That's all, folks. I'm curious. I'm going to have to look that up.
It's the